So we are continuing on here with 4.3. And this is basically a continuation from last class. So you had said that you didn't watch last class. Some of this might be confusing because you haven't seen it. But this builds on top of that. So there is something that we're going to use. You don't really need to know this whole formula. The essential part that you'll need to know is this, because this is on your calculator. So if you look on your calculator, you'll be able to find this NPR, and we're going to use that exclusively today. The P stands for permutations. Once we get to 4.5, I believe it is, we're going to switch to a C. But I'll get there at some point. So we just need to deal with this today. And I'll show you what each of these numbers mean with examples. So in this first example here, so Matt downloaded 10 new songs from iTunes. He wants to create a playlist using 6 of these songs in any order. And we want to know how many 6-song playlists can be created. So in order to do this, I'm just pulling up my notes here. Okay. So there's 2 ways we can go about doing this. I'll show you the long way first, and then I'll show you the short way. So if we want a 6-song playlist, I've got 6 spaces that I can fill. 1, 2, 3, 4, 5, 6. So here's the first song, here's the second, here's the third, fourth, fifth, sixth. I want to fill these up. So how many options do I have for the first slot? So I've got, I want the 6 songs, and I've got 10 songs I can pick from. So how many options do I have for this spot? We're gonna start at the other end. So instead of starting at the 1, we'll start at the 10. So I can pick any one of these 10 songs to go first. And then once I've used up one of those songs, how many songs are left over that I could pick here?
9.
So then it's going to be 9, yeah. And then 8, and then 7, and then 6, and then 5. So in order, because of the fundamental counting principle, if this is the number of options for the first, and this is the number for the second and third, in order to get the total, I just multiply these all together. If I do this, it gets me a really long number, 151,200. So this is the number of playlists that I could have. So this is the long way. This is setting out, okay, how many spaces do I have? How many songs do I have? Write it all out. This is where this comes in handy. So how I'm going to use this is the n is the number of options that I have. So I have 10 options total. I'm going to do a permutation, and I want 6 of them. So 10 being the number of options, 6 being how many I want. And if you plug that into your calculator, you'll get the exact same number. So this is going to be a whole lot easier than writing out this whole thing. Does that make sense? So essentially, what we're saying from this is I have 10, choose 6. I have 10 options, I want to choose 6 of them. Plug that in, you'll get your total number. So let's try this for a different example here. So we've got Tanya needs to create a password for a social networking website. The password can be any digit from 0 to 9 or any letter. The password is case sensitive, so you got upper and lower case numbers. A password must be at least 5 characters to a maximum of 7, so it could be 6 numbers, letters, 7 or 8. And each character can only be used once. So we want to know the number of different passwords. So this is a lot. Hi, Kareem, you with me today? You with me today? Because I'm already in the middle of my lesson. So we need to deal with something like this. So we've got 3 different cases I can deal with. Either I'm going to have 5 characters up to a maximum of 7. So I could have 5, I could have 6, or I could have 7. So if I've got different numbers or the amount of numbers I could have, I need to deal with those separately. So first, we need to look at case number 1. And case number 1 is if you have 5 characters. So if I've got 5 characters, we're going to use the P method here. And we're going to look at, let's see, I'll put it over here. I need to figure out how many options I have, and I want 5 because I'm doing a 5-character password. So we first need to figure out how many options total do I have in this case. So in this, I've got the numbers from 0 to 9. So that's 10 digits there that I'm dealing with. I can have any letter. Any letter is 26, but it says I can use both a lowercase or an uppercase. So therefore, I've got 26 lowercase, 26 uppercase. So therefore, the total number of options I have for this is going to be 62. Does this part up here make sense? Where that came from? Okay, perfect. So I've got 62 options. So in order to figure out how many 5-character passwords I'm going to do, I have 62 options for what I can put in the password, and I want to pick 5 of them because I cannot repeat. So this, you just need to plug into your calculator. You'll get some number. Did I write it out? No, because it's a big number. So I'm just going to, I'm going to just leave it at that. Now let's look at case number 2. This is if I have 6 characters. So what would be my permutation equation for this, do you think? Yeah, exactly. So if I've got 66 characters, it'll be 62 P6. And again, you can just plug that in the calculator. So not too bad. Let's look at the last case here. We've got 7 characters. And again, straightforward, picking from 62, and I want 7. Any questions with that so far? Okay. So if I want the total number of passwords, I'm just going to take the number in case 1, the number in case 2, plus the number in case 3. So I'm going to add these together. And if we add them together, it's going to be a rather large number. 2, 5, 2, 3, 6, 9, 0, 7, 8, 0, 0, 0, 0. So how many is that? Hundreds, thousands, millions, billions, trillions. So 2.5 trillion. So if you can think about passwords, if you were only allowed to pick these, and you had between 7 and 5 characters, you've got 2.5 trillion passwords. So throw into their symbols, throw in their passwords that can be smaller or bigger than this. You can make a whole lot of passwords. So this is the strategy of making passwords. There's just a lot of them. Make sense? Okay. Is this my last page? Yeah, okay. So here's where things start to be a little bit tricky. So the stuff we did before, we talked about a situation where there is no restrictions. So you're told, I just want 6 songs out of 10. But let's suppose now I'm going to put a restriction on that. So for example, if we talked about the songs, saying I want 2 songs to be together. So they have to be first and they have to be together. I'm placing some sort of restriction on that. So if we look at this example here, we've got a used car lot. I've got 7 different car models, so 7 different cars. And I'm going to restrict this so that the 3 red cars must be parked so that there's one at each end, and the 3rd car is exactly in the middle. So we want to know how many ways can we park those 7 cars. So this example, it's really good if you actually draw this out. Otherwise it's going to be confusing. So I've got 7 cars, so we'll go 1, 2, 3, 4, 5, 6, 7. And we are told that I must have, does it say anything about the other ones? No. So I must have a red car here. I must have a red car here and in the middle. Those are the only restrictions. So if I look at this, let's deal with the red cars first. How many options do I have for putting a red car here at the first spot? So if I were to look at the first spot here, how many options do I have for red cars? I'm just putting 1 car here, but I've got 3 red cars to pick from. So the number of options I have here is going to be 3. And then how many options do I have for a red car here? 2. And then 1. Good. So I've dealt with the red cars. The other cars we're not told anything about, but there's no restriction on that. So how many cars do I have left over that could be in this spot?
4.
Yeah, so I've got 4. Then I've used one of them up, so I've got 3, and then 2, and then 1. So this is how you would lay this out. This is the best way to do it, is to just draw it out and see, okay, how can I rearrange these? So if I want the total number of options, times all these things together, and this gives us 144. I find this is the easiest way to do this. If you wanted to, you could use the P equation for this as well, and you could just say the total number here is going to be looking at the red cars. So I have 3 red cars. I want to pick 3 of the red cars times I've got 4 cars left and I want to pick all 4. So you could do it this way as well, which this is, it should give you 144 as well. Let me just double check to make sure I didn't make a mistake. Yep, that works. That one make sense? Okay. So let's try this next one. So I've got 3 red cars that are parked side by side. So now how many ways can these 7 cars be parked? So in this case, I've got the restriction that my 3 red cars have to be side by side. So when I lay this out, so if I did it like this, so let's say I put all 3 red cars here first. So again, I'm going to have to deal with the same thing, 3, 2, 1. But the thing is, with this, the 3 red cars don't have to be first. I could switch it so that the 3 red cars are second, or the 3 red cars are third, and I can shift them in different spots. So in order to figure out the rest of this, what I'm going to do, because they're all side by side, I can treat these 3 red cars as one single unit. And I can shift them all together. So this would be like, let's say I've got these 5 pens. So if I had no restrictions, I can move them in any order. But if I said these 2 pens have to be together, so I could arrange them like this, I could put them second like this, I could put them third like this, or switch it like this. So I'm essentially treating this as one item and shuffling it between all the others.
Does that affect the total outcome of the total number?
Yes, it will affect that. Because as you can see here, right now I've got 3 ways, or a certain number of ways I can do this. But then if I'm looking at this whole outer side, I'm arranging not just 4 items, I'm arranging 5. I've got 1 car here, 1 car here, 1 car here, 1 car here, and I'm going to treat this as another car that I can shuffle with all the other cars. So if I wanted to look at the whole system, so this part here is our 3P3 is just dealing with the red cars. If I'm looking now at this whole system, I've got 5 options, this car, this car, this car, this car, or this whole system, P5. So this is where it's going to change, is now that those ones can move, it'll give me some different options. It's different than this one because my red cars were planted. I couldn't move those red cars. So if I want to get the total here, I just take these 2 things and times them together, these 2 permutations. So this gives me 720. So you can see it does quite drastically change the number from the first one. Questions with that? Okay. I'll give you a sec to write it out. So now let's try some numbers. And then this is the last little bit. Okay, so you don't need to know anything about social insurance numbers. It's just something that we have in Canada. And it's a 9-digit number that have the numbers from 0 to 9. So it just means 0, 1, 2, 3, 4, all the way up to 9. So we've got 10 different numbers you could have. If there's no restriction, which this is often going to be what we're dealing with for this unit, is talking about looking at the restrictions and how does that change our outcome. So if there's no restrictions, we want to know how many social insurance numbers can be created. So in this case, I've got a 9-digit number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If there's no restrictions, my first number can be any number from 0 to 9, so I've got 10 options here. My second number, there's no restrictions, so this is 10. I can put any number in here. So these can all be 10. So because I'm picking numbers, I'm allowed to repeat numbers. As opposed to something like this, I'm picking cars. I cannot repeat the same car because I only have one of those. Whereas this, I'm allowed to repeat any numbers because I'm not restricted to say there's no repetition, which we'll get to down here. So if you times all these together, so I got 1, 2, 3, 4, 9. So times these all together, you'll get 10 to the power of 9, or 1 with 9 zeros. So 1 billion. So how would this change now if we said there's no repetition? What do you think would be different in this case? Yeah, exactly. So instead of being able to go 10 times 10 times 10 times 10, once I've picked something for the first one, the second one cannot have that number. So it'll be 10 times 9 times 8. And because of that, I can now use this permutation equation where I have 10 and I want 9. So I can use this anytime there's no repetition. I can use this equation to make my life easier. So if you plug that in your calculator here, you will get 3,628,000 different options. So it gets a lot smaller. Just in a general case, I just remembered this. So if this is your equation, NPR, the n value must always be greater than or equal to the r value. Otherwise, this won't work. So if you're confused, where do I put the 10, where do I put the 9? Put the bigger number first, and then the smaller number second. So let's look at another restriction here. So it says, in reality, the Canadian government does not use 0, 8, or 9 in the first digit, but the rest you can use whatever you want. So if I'm looking at this equation here, how does restricting this affect what I've got up here? What do you think? Not for the first digit. Everything else is okay. Mm-hmm. Yeah. So if we were to write this out again, so if we were to write out our 9 digits, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I haven't affected all the other digits, so those all stay 10. But how many options do I now have for the first digit? Mm-hmm. So if my digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it says only for the first digit. So they don't use this for the first one. So here, you can't use that. But the rest of them you can. It's just the first one that it affects. So if for the first digit we're told we can't have a 0, we can't have an 8, and we can't have a 9, how many options do I have left to go here? Yeah. So I've only got 7 options for the first one, but the rest can all be 10. And then you just multiply those together. So this will equal 7 times 10 to the power of 8. And if you wanted to write that out, you could just as 700 million. But either one's fine. Questions on that? Okay, so that's the section. So really the tricky part with this is going to be, okay, in which case can I just simply use the permutation? And that will just be, there's no repetition, and there's not really a fancy, any other kind of restrictions, but drawing things out with these dashes, I find that really helps. When I'm solving these questions, putting those will make a difference. So when you read the question, you'll need to look at, is repetition allowed? Are they allowed to be repeated? Because that will change what numbers I put in here. So you'll just need to read the question carefully to figure that out.